All right, so today we are talking about reflections. So we already did translations. Today we are talking about reflections. Okay, so reflections is basically like looking in a mirror. Basically, when we're looking in a mirror, let's do a practical example here. Let's say this is my mirror. Okay, and let's say, I'm just going to use all the stuff around me. So let's say this remote is looking in the mirror. Its reflection would be about the same distance away, right? If it took a step back, its reflection would take a step back. If it took a step forward, its reflection would take a step forward. Your reflection is basically the same distance away from that mirror wherever you look at it, right? If you take a step back, your reflection takes a step back. Same idea. Basically, that's the idea with the shapes. Basically, your reflected shape is going to be the same shape, just reflected the same distance away on the other side. Okay? So let me show you what that looks like. So, let me give you a couple of, let's write a couple examples in here. So some visual examples. Okay, and again, reflections are same distance from line of reflection. Okay, so let's say I have a triangle, kind of the same idea that we had with translations. Got a triangle right here. Let's say this is point A. Okay, obviously there's 3 points, but we're just going to focus on 1 point. So let's say we want to reflect that across the y-axis. So if you think about it, this point would be about the same distance away, right? So it would be right next to the line. Same with that point. But A is going to get pushed clear over here. That would be my new A, right? That would be A prime, because it's about the same distance away from the line of reflection. So that's kind of what it does. And if you look at that, it kind of flipped the triangle over, right? That's going to be the action word that we write down here in a little bit at the very end. But reflections basically flip your shape around. Okay, so if we are reflecting across the y-axis, there's something that happens to our ordered pairs. Okay, and that basically is that the x is going to change signs. It'll be the same numbers, just the x is going to change signs. So for example, if you just have your generic x and y here, if you reflect that across the y-axis, it would become a negative x and y. Okay? So whatever the sign is, it would change. So let's say I have, let's do negative 4 and negative 4 as an ordered pair. It would become positive 4 and negative 4. Okay, so just the x would change signs. That's what happens when you reflect across the y-axis. Okay, so it's just basically changing stuff horizontally, right? Your vertical points are all in the same spot. Just your horizontal points are changing. So let's look at an example of where we reflect across the x-axis. So again, let's say I have my triangle here. If I'm reflecting across the x-axis, so again, let's say this is, let's call this A here. So let's call that A. So if I reflect across the x-axis, then A would get pushed over here, become A prime. But again, same triangle. I mean, it should be about the same triangle. I may not be the perfect drawer, but that would be about the same triangle. And basically what happens when you reflect across the x-axis, is that the y changes signs. So generically, xy is going to become x negative y, or whatever the sign was would change. So if I had 1, 4, that would go to 4, or become 1, negative 4, right? So that's basically about where A was, right? It was at 1, 4, and then it became 1, negative 4. So that's basically what happens when you reflect across the x-axis. Now, if it's just a line, so say something like this. So let's say it's y equals 2. So this line right there. So just a horizontal line. And I have a shape right here, triangle. Basically, you would count from each point how far away it is from that line, and then your new triangle would be, those points would be that far away. So let's say like this point is 3 away, that means I would go 3 past it. That would be my new point. Say this is like 5 away, so I'd go 5 past it, that would be my new point. Same here, it's like 5 past it, so that would be my new triangle reflected right there. So that's what happens if it's just a normal line. You actually just have to count to the line of reflection and then count that far past it. And I'll do an example of that in a second. And I wasn't actually planning on putting that in the notes, but if you want to put that in there, that's fine. But, because there's no rule or anything that happens with that, it's just you have to count. You have to count to it. Okay? There's a couple others that have rules that, and it's nice to have rules because then we can just quickly change it depending on what the signs are if we know the ordered pairs. So the ones that students usually have struggle with, like all this stuff students generally do okay with. The ones they usually struggle with are our diagonal lines. So y equals x, if I were to draw a coordinate plane with that line, y equals x would have a y-intercept of 0, 0, and it would have a slope of 1 over 1, right? So it's just that perfect diagonal line that cuts your coordinate plane kind of in half diagonally. That's y equals x. So let's be a little bit more specific on this example, because I want to show you guys how this works in a little bit more detail. Okay, so let's say I have a point at 1, 2. Let's call it C. Okay, so we'll call that C. I don't know why I did that in red, because that's what I do my transformations in. So I'm going to change that to black. We'll do the next one in red. Okay, so let's call that one C. And what happens when you reflect across y equals x is the x and y switch spots. So x and y switch. Yeah. Okay. So basically, if I have my generic ordered pair, x, y, it would become y, x. So they really just change spots. So since that C is at 1, 2, the new C would be at 2, 1. So 2, 1 would be C prime. If you look at it, that's about the same distance away from the line of reflection, the diagonal line there, right? It's just a little trickier to count to a diagonal line because it's got that horizontal and vertical aspect. So a little bit easier if you know the rule to do that. If you wanted to do it where you were just counting to it like I showed you up here with just a normal line, you would have to count up to it, and then however that was away, then you would count over. So like this is at 1, diagonal line is 1 away, so I would count 1 over, and that would be my original C, right? Okay. Then the other diagonal line that we talk about is y equals negative x. So if I were to draw a coordinate plane here, and let's say, we'll do this again. Negative x would be the line that would go directly through the origin at a slope of -1 over 1. So basically just, again, cutting the coordinate plane in half diagonally just with a negative slope. Okay? So if I write in C again here at 1, 2, we're going to talk about how that changes this time. So basically what happens is the x and y are going to switch again. But both change signs. So basically your generic x, y is going to go to -y, -x. So they just basically switch spots and change signs. So for 1, 2, that would become -2, -1. So if I plot that out, -2, -1, that would be my new C right there, C prime. And again, you look at it, it's about the same distance away from the diagonal line. If I had drawn like a more perfect graph, it would be the exact distance away. But you know how I am. Okay. And then our action word for this transformation is flip. So this time we are flipping shapes around, right? Or points, as I just talked about. So I'm going to give you guys a look at everything I just wrote. If you want to freeze and copy it down, it's right there. Okay, then let's do some examples. So, looking at our book here, let's look at an assignment. Let's look at this one. Okay. So, looking at our problem right here. Again, I told you I would talk about how to reflect across a line in more detail here. So let's do that. X equals -1 is going to be this line right here. Okay, that's x equals -1. So I want to reflect across that line. And again, remember I showed you the demo how like your line reflection is the same distance apart, right? When you take a step, your reflection takes a step, all that kind of stuff. So basically to reflect across this line, I'm just going to count to the line. So this is my original point right there, right? P. So I would take P and I would count to the line, and it's horizontal, so I count that direction, right? So P is one spot away. So to reflect it across, the new P would be one spot on the other side away. So that would be P prime right there. It's exactly one spot away. Reflected image is the same distance away, just on the other side of the line of reflection. Okay, same thing with H. H is 1, 2, 3 spots away. So I would go 1, 2, 3 spots away on the other side. And there's your new H prime. Okay, Q is 1, 2 spots away, so the new Q would be 1, 2 spots away on the other side. There's your new Q prime. And there is your reflected shape right there. Again, just kind of flipped over that line, right? And that's basically all you're doing right there. Okay, let's look at another one. So reflect across y equals -x. And again, I told you guys that's that diagonal line. Kind of goes through here. Okay, so as you can see, U is already on that line of reflection. So U prime isn't going to move. It's still there. Okay, now I have a couple ways I could do this. Like I said before, I could count vertically and then count horizontally, and that would give me my shape with these diagonal things. So, but before I do that, I want to show you guys just how it works with the points. So remember, with the ordered pairs, basically what happens is it just flips and changes signs, right, on both. So if you were to look at, like, for example, U is 1, 2, 3, 4, 1, 2, 3, 4. So it's -4, 4. If I flip those around, change their signs, it would be, if I flip them around, it would be 4, -4, and then change their signs, it would become -4, 4. So same spot, right? So U is right there. Let's look at V, though. V is at -4 and 2. So it's originally negative 4, 2. So that's going to become negative 2 and positive 4. So they flipped and changed signs. So V is at negative 2 and positive 4. So there's my new V prime. And then P is at negative 3 and 2. So negative 3 and 2. And that's going to go to negative 2 and positive 3. So when I do that, negative 2, positive 3 is right there. There's P prime. Now, let me show you what it means when I say you can count to it. So, for diagonal lines, like here I just counted straight over, right? Because it's a straight line. With diagonal lines, you have to count vertically and then horizontally. So if I count vertically, it would go 1, 2, and then I'd have to go 2 horizontally. There'd be your new P prime. And same idea, up 1, and then I'd go right 1. You could also go horizontal and then go vertical. You're going to end up in the same place. You just got to change directions when you get to your line of reflection with the diagonal. Where here, you're just going the same direction. Okay? Let's do one more example here. Let's do a reflect across y equals negative 1. So y equals negative 1 is this line right here. Oh, nope, that's y equals 1. Y equals negative 1 is this line right here. It might have been cooler to do y equals 1, but we'll do this. So, negative 1 is right here, so basically from each point I count to it and then count that far past it. So m is 1 away, so the new m would be 1 past it. There's m prime. J, I think is what that is 1, 2, 3, 4, so I'd go 1, 2, 3, 4 past it. There's the new J prime. L is 1, 2, 3, so I'd go 1, 2, 3 past it. There's your new L prime, and there's your reflected shape right there. Again, it just flipped right over that line. Okay, and one more thing I want to talk about before I go is when it says write a rule to describe each transformation. With reflections, basically all it wants is it wants you to write what the line reflection is. If it reflects across the x-axis, you just say reflect across x-axis. If it reflects across the y-axis, reflect across the y-axis. If it reflects across y equals negative x, you just write reflect across y equals negative x. If it reflects across a specific line, like x equals 1, you'd write reflect across x equals 1. So the trick here is to figure out what line it's reflecting across. So basically to do that, you basically look at the 2 points, any 2 points that have changed. So if I look at the L's, I want to basically look at what's halfway between those 2 L's. If I look, it's right here, right? That means it reflected across that line right here. This is the line that these shapes are reflecting across. And I can check it by basically counting from each point, right? L is 1 spot away, U is 1, 2, 3, 1, 2, 3, yep. C is 1, 2, 1, 2, yeah. So it matches, right? That's the line of reflection. That line is not the x-axis, it is the line right above it, which would be reflecting across y equals 1. Remember, y equals is the horizontal lines, x equals is the vertical lines. So reflect across y equals 1. And that's all you have to do. Okay? If you look at 17, if we look at G's, they're right on the same thing. They're basically on the line of reflection, right? But everything else looks like it's diagonally reflecting. So what line would be diagonal? What's cutting through here? It looks like it's that diagonal that goes negative direction, like this, right? That looks like what they are reflecting across. And remember, that is the negative x. So this is reflecting across y equals negative x. Okay? And that's basically all you're doing for reflection.